This innocent looking integral has confused even the brightest JEE minds. At first glance, it looks like a mess, but hidden inside is a beautiful trick involving symmetry. Can you crack it before I reveal the trick? Let's solve the question. At first glance, you might think of direct substitution, but it won't work here as it will make the problem more complex. Let's define our integral as I, and we know that sin pi minus theta will always be equal to sin theta, and similarly cos pi minus theta will always be equal to minus cos theta. So we can write that cos² pi minus theta will be cos² theta. We'll use the property of symmetry for definite integral. Here in this case, our lower limit is 0 and upper limit is pi. So this will directly become f of pi minus x dx over the limits 0 to pi. We know what our integral is, so we will just replace pi minus x in place of x, and we will get the other half of the equation. Now we'll use the values of sin pi minus theta and cos² pi minus theta in this equation. Here theta will be replaced by x. So this is our final equation. Now we can just separate pi minus x in two different terms and expand the integral. Now we can see that the second term is equal to I, which was in our question. So we can just write that term is equal to I. To make the problem a little simple, we can take I from right hand side to left hand side, which will become 2i, and then we just have one term left. Now there is no single x term in the integral, which will become easier to solve. Now we can try the direct substitution method, where we can substitute cos x is equal to t, and differentiating this we can get minus sin x dx is equal to dt. Here we can get the value of sin x dx as minus dt, and then we can use both these values in our equation, which will make the equation look like this. Now we know that integration of 1 by 1 plus t square dt is always tan inverse of t. We'll change the limits to, as cos 0 will be 1 and cos pi will be minus 1, which we made a slight error in sign, and then we can change it a bit later. And now we'll just expand it like f of b minus f of a, and then it will be tan inverse minus 1 minus tan inverse 1. We know that the value of tan inverse minus 1 is minus pi by 4 and tan inverse 1 is pi by 4. So we can just simplify this, and this will be 2 pi by 4, and a final answer will be pi square by 4. Did you solve it on your own way? Drop your method in the comments. I would love to see it. And if you enjoy solving challenge in math with us, don't forget to like and subscribe.